Let's just kick things off with this one idea, because it's pretty powerful. Intelligence is now an infrastructure problem. I mean, think about that for a second. The last time you used a map app on your phone, it wasn't just some clever algorithm, was it? No, it was backed by a gigantic infrastructure. Servers, data centers, real-time data feeds. That's what this quote gets at. AI, it isn't just about writing code anymore. It's about building these massive, robust, global-scale systems that actually bring that intelligence to life.
And with that, a huge welcome to Module 2 of our series on AI and machine learning. Over the next few explainers, we're going to pull back the curtain on what it really takes to build the autonomous future. Yeah, we're talking about the architectural blueprints, the nuts and bolts, and the real-world challenges of making truly intelligent systems a reality.
Okay, let's dive into this, because this is a big deal. We're all pretty used to asking a chatbot a simple question and, getting a direct answer. It's a single interaction. But what if you could just ask an AI to plan your entire vacation? I'm talking booking the flights, finding the hotels, creating a whole itinerary. That's the new world we're stepping into. One where AI systems don't just react to you, but they autonomously plan and execute complex, multi-step tasks to get things done.
Now, to navigate this complex new landscape, we need a plan. So we're going to use a framework we call the Sentinel approach. You can think of it as our blueprint for designing these next-gen systems and doing it with the kind of reliability and security you'd expect from a Sentinel. We're not just building AI for fun. We're building AI you can actually trust to do the job.
This approach really stands on three core architectural pillars. First up, you've got the reasoning engine. This is the brain, right? The cognitive core of the system that actually thinks and makes decisions. Second, the automated factory. This is the MLOps platform that's constantly building, deploying, and maintaining our models. And third, the raw power. That's the underlying infrastructure, the sheer computational muscle that makes all of this possible in the first place. So let's start with that first pillar, the conductor of our AI orchestra, if you will, the reasoning engine. This really represents a fundamental shift in how we think about AI. We're moving away from simple, reactive models to what we call Agentic AI, which can basically orchestrate a whole suite of tools to accomplish a goal.
So, what's the real difference here? Well, a simple chatbot is kind of like a helpful librarian. They can find a book for you from the catalog, which is great. But an agentic AI, that's more like a full-on personal assistant who not only finds the book, but then orders it for you, schedules a time for you to pick it up, and even reminds you when it's due. See the difference? It's about getting an answer versus actually getting something done.
In this slide, this lays out the formal definition perfectly. Just notice how that AI model is sitting right there in the center, acting as the reasoning engine. It's not just spitting out text. It is an orchestrator. It's connecting to APIs, it's querying databases, and it's using a whole toolbox to execute a plan and make things happen in the real world.
Okay, having a brilliant reasoning engine is one thing, but how do you build, deploy, and manage these systems reliably, especially when you're talking about massive scale? Well, that brings us right to our second pillar, the automated factory. Think of it like a high-tech assembly line, but for our AI models, automating the entire process from start to finish.
A really solid MLOps platform, our automated factory, creates this continuous cycle of improvement. It all kicks off with preparing and validating data, then it moves to training and evaluating the model. Once that model passes all its tests, boom, it's automatically deployed into production. And from there, it's constantly monitored to make sure it's performing exactly how we expect. It never stops.
You know, the really crucial point here is that automation isn't just some nice-to-have feature. It is absolutely essential for production-grade reliability. I mean, think about a self-driving car for a second. You wouldn't want its software updated manually, would you? Of course not. You'd demand an automated system that can deploy critical updates instantly, reliably, with zero room for human error. That is the power of automation.
And finally, none of this, not the brain, not the factory, none of it is possible without our third pillar, the raw power. This is the engine room of our whole operation. It's the foundation providing the sheer computational force needed to power these incredibly demanding intelligent systems.
And what's really interesting here are the specifics. We're talking about specialized hardware like TPUs, tensor processing units, and GPUs. These things are custom-built for the massive parallel computations that AI requires. The architecture has to be scalable so it can handle huge swings in demand, and it must be designed for high availability because, let's be real, production systems simply cannot go down. And all of this is supported by high-performance storage that can feed insane amounts of data to the models at blistering speeds.
So those are the three pillars of the Sentinel approach: the reasoning engine, the automated factory, and the raw power. Now that we have that big picture,
Let's zoom in on the specific technologies and concepts we'll be exploring for the rest of this module.
And we are absolutely going to get hands-on with these concepts. We're going to explore specific agentic design patterns for building smarter systems. We'll dive deep into something called GraphRock, which is a cutting-edge technique for giving our models way better context. We'll show you how to automate that MLOps lifecycle with powerful tools like Vertex AI. And we'll get into the nitty-gritty of scaling with massive TPU clusters and using high-performance storage like Managed Lustre. It's going to be a deep dive, and it's going to be awesome.
Look, this isn't science fiction anymore. The components, the blueprints, the platforms, they are all here today. The autonomous future is being built right now as we speak, and you have the power to be a part of it. So the only real question left is, are you ready to build it? Let's get started.